In this video, we're gonna make this control panel with all these knobs and switches using the Atomstack X7 laser engraver, just as soon as I get it out of the box. Before we get started, I wanna give a huge thanks to Atomstack for sending this laser engraver out for me to share with you on this channel and use for this project. So let's get going. I've been 3D printing things for a few years now, making random things that I use around my studio, like this charging wall or these little stands that hold up these little blank cards, and even this little SD card holder for a wallet. But there are some things that 3D printers are just not the best tool for the job. In particular, large flat surfaces like panels. Like, for example, when I built this breakout box for these SDI and HDMI ports, I first had made a version of the top that was 3D printed, but it turned out way too flimsy, so I actually went and found a company who cut this out of metal instead. So now I want to build a panel to mount all of these knobs and switches to build the Chaos router, and 3D printing it just wouldn't be the best option. What is the Chaos router? Well, I'm glad you asked. The Chaos router is a device that I'm building that will help me test how different live streaming gear handles poor network conditions. It is a router that lets me control how much bandwidth and latency that the connection through it has. Once I give it an internet connection, I can plug in a streaming device like an ATEM mini or a YoloBox, and then I can actually use it to simulate how that streaming encoder might work in the real world once you're on a poor cellular connection and not in your studio with gigabit upload speeds. I've got a long list of gear to test with this, so I'm excited to finish actually putting this together. So that takes me to this box that just arrived. This is the Atomstack X7 laser engraver. Now, I've never used a laser before, so this is going to be a bit of an adventure to get this all set up and working. This video is the first video in a series to build this Chaos router, starting with carving the top panel out of a piece of wood with this laser. So make sure you subscribe so you don't miss the next videos in this series. So let's get this laser out of the box and see what we're working with. This looks complicated enough that I should probably actually read the directions, so let's open up this manual and give it a try. Okay, now I've got things mostly assembled. It slides on the rails, both directions. Laser module is in. Little belts are installed, so now it's time to do the wiring. The instructions are a little bit sparse on this, but I think it's pretty straightforward. Pretty much just plug everything into where it fits. Start with this little one down here. And it looks like we have a connection for the motor and a connection for this sensor. That stopper. This one goes up to the laser. Got the motor. And laser. I think that's it. All right, it's all assembled. Before we go turn this on, there were a few other boxes that they sent as well. So let's take a look at what's in these other boxes to see what we've got. This box is the Air Assist Kit. This is basically a little air pump which can force some air down into the laser to help cool things off or keep the dust from collecting, and it's supposed to make the cuts look a lot better. So I'm actually going to go ahead and install this because this is another step of running some tubing and more wiring. And this is actually made to fit a whole bunch of different laser modules. So there's little adapters for all the different versions of this that they sell. And the instructions have a whole bunch of different model numbers mentioned. So I've got the X7 here, so we're going to go ahead and see what I need to do for the X7. It looks like I'm going to need to replace the little air guide that's already in there. So let's slip that out. Okay, that came out. And I guess we look for the matching one of these. Okay. That the glass in. Number one. Okay, then the tube. So it's just going to blow some air right into the tip. And stop this little thing from rolling around. Now I just have to live on the bench. That in the farthest position. Another accessory that they sent is this
a very large cutting mat. This is a honeycomb mat, which again is supposed to help the quality of the cut, because instead of burning onto a hard surface, you're burning through this, and there's room for air ventilation, and especially with the blower, it can actually get some air movement. Protect the bench with a metal sheet. Got some little things in here as well. Another accessory they sent is the AC1, which is this camera contraption that puts a little camera over the top of the laser cutter, which is supposed to help with centering and positioning things in this area. So this is looks like a pretty quick assembly. So let's go ahead and get this out of the box as well. It looks like we can just that. So my eventual plan is to mount all of these knobs and buttons to this piece of wood. This is an 1/8 inch piece of plywood. And that means I need to figure out what are the right settings to use for laser power and speed in order to actually be able to, one, cut through it all the way, and two, make some etching on the top for the labels. Every material you get is going to act slightly differently. It'll take different amounts of power to get through or to burn. So the first thing I'm going to do is open up my software and actually make a little test card to test the laser at different power settings. This is the Atomstack X7 laser, which is a 50-watt laser. Now, one thing to keep in mind about the laser power is that you'll often see the power rating as the input power, not necessarily the actual laser power. So on the website, this says it's a 50-watt laser, but notice down here, it says it's a 10-watt laser power output. Some of the other ones are 5-watt outputs, which will be obviously a lot less. Some of the more powerful ones will get up to 20 watts, and then the really serious lasers can get up to 50 or much higher. And again, the laser power will have a huge effect on how fast you need to cut and how much power you need to use to get through different kinds of materials. So I'm always going to do a test burn on the particular material for the particular laser that I'm using. As far as software goes, I'm going to use Lightburn. From what I've seen, this one is relatively easy to use and reasonably well built. So I'm going to use this. It's not free, but there is a free trial. If you do want to purchase it, then you'll need to get the $60 Lightburn software G-code license key in order to use it with the Atomstack X7. So I've got the Lightburn software installed, and before I even connect the laser, I'm just going to go ahead and make my little test pattern on here, and we'll connect the laser and set it up later. So I'm going to make little boxes. I'll make a grid. We're going to test two things. We're going to do across the x-axis, we're going to test power, and on the y-axis, we'll test speed. So we're going to have to make a bunch of little boxes and then change the settings for power and speed in order to be able to see how this all works out. I'm going to first just draw a little box, and I'll set the dimensions manually. I'm going to make it 10 millimeters by 5 millimeters. We'll make these little rectangles. To zoom, I find it a little difficult to navigate this, but scrolling in will zoom in to where your cursor is positioned. So this is our little box, and this is a little black square. It's showing up on layer 0. This is also something that was not obvious at first when I started using Lightburn. These are layers, and if you click on them, it'll actually, if you have something selected, it'll change what layer that's on. So as I make more of these, we're going to end up with more layers, because the layers is where you can change the speed and power settings. So I've got a box. Let's use the replicate tool to make a few more copies of it over to the right. We'll make 10, and they're 2 millimeters apart, and that's fine because we're going to end up cutting, we're going to try to cut through on these. So now we've got 10 boxes, and they're all on one layer. If I do this again and go down one layer, let's make these also 2 apart. this is where we're going to move these to layer 1. Now this is going to tell the laser what to do. I actually want these to be lines, not fills. So I'm going to test cuts first, and then later we'll test what happens to fill in for lettering. So these are going to be lines, and now the laser will trace the little box as it goes. The speed for layer 0 is 150, the power is 100%. I'm going to first do a quick Google search to see what's like a reasonable range to expect for a 10-watt laser going through wood, because I don't want to just, otherwise there's too many possibilities. So let me look that up really quick. Okay, quick Googling was not super conclusive, but we're going to go with starting with 100 and see how far we can get, maybe up to 1,000. So I'm going to start with 100. This is, again, millimeters per minute is the unit here. So if you're looking things up, make sure you're looking at millimeters per minute and not millimeters per second, because that would be a whole different scale. We will set max power to 100%. We'll change the power later. Number of passes is also something you can vary. From what I've seen, it looks like you get better cuts if you do multiple passes instead of trying to do the whole thing all the way through in one pass. That'll be obviously different if we're just doing shading for lettering. We'll just stick with 2. That's another thing we can vary, but we can test that on a different card later. So with that one set there, we're going to go ahead and set this one to 150. And we're just going to keep doing this until we get up to, I don't know, 1,000. I'm going to go ahead and now make a bunch of rows of these. And then we're going to have to change the layers of each one. That's where the speed setting is. So grab those, move them to layer 2, change layer 2 to 200. Now I just realized I did this wrong, because I should probably have put the power setting in these before I duplicated them all. The power setting you can change per object instead of per layer. So I want the, let me add labels to these actually before we get too much farther, so that we can actually keep track of what we're doing. I want that to be 10, which will be 10%. And I guess this is going to go on the top layer, layer 29. You have to take a wild guess for that to score it. We do want to fill that one. That's too hard to read. Let's put it on 27. Make it darker. A little bit smaller. And we will copy and paste it. Okay, 10. This will be 20%. So, okay, the power setting you can change on the object. So if you right-click and go to properties of the object, power scale, we're going to set this to 10. This is actually going to be 10% of whatever the layer setting is. And that's why I set the layer power max to 100%. So we're going to do that for all of them. Can I select all of these and change them? I hope so. Double check that worked. Yes, okay, good. I don't have to redo all of these. They're all 10. Okay, let's double check everything, because I see some of these got set to 20 somehow. I think it happened when I when I duplicated the text layers, which were set to 20%. So we want to make sure these are all set to maximum power 100. The labels are fine. Let's actually move those up so that it cuts those first. Well, I guess we're ready to do a test. So let's plug this into the laser and get that configured and see if this is anything close to accurate or if it's way over or way under. I just realized this is actually pretty big. This is like almost 5 inches. So I'm going to scale everything down half. I think I can just scale the whole thing. Let's lock the ratio and then just go 50%. That looks better. Now that's only 70 millimeters. Don't want to waste too much wood on the test cuts. All right, let's connect this up to the laser and see how it goes. All right, welcome to the messy side of the studio. Over there is the clean side. This is the unfinished garage side where I've got all my tools and now the laser cutter. So we're going to power this thing on, do that quick test burn of the test pattern and see exactly if it worked. Use those settings to determine what we're going to use for the actual cut of the board, the panel for the chaos router. So I'm going to go ahead and plug this in, plug in my computer, and we'll run the test burn. Okay, we've got the laser turned on. That noise you hear in the background is the air assist blowing air through the little nozzle, but the laser is powered up, connected to the computer, ready to do the test cut. But first, most important thing is goggles. Laser goggles tuned for this wavelength of light. I definitely want to make sure that my eyes continue to work. So I'm going to be wearing these at all times. Now everything just looks red. I can still mostly use my computer, so I have something to keep these on while I'm working. Now I don't have the camera connected yet, and I don't want to bother with that until I get one of these test cuts done. First thing I'm going to do is I made this device, which is the Atomstack X7. And I'm going to actually go edit the device properties because there is a feature called Enable Laser Fire Button and Laser On when framing, which is going to let you see the dot. It's going to turn on the laser very dim and trace the outline of it, and we'll see where that is, and that'll help us line it up on the rectangle. So I'm going to set the power to just 1%, and that'll just be a very dim dot that'll light itself on the cardboard. So the way I'm going to do this without a camera is use this frame button, which will go around this. I've got job origin set to that corner. You can see it moves this dot around if I change the origin. So the job origin is there. So wherever the laser head starts from, it's going to trace that. So let's go over to the laser and set this up. So with my goggles on, I'm going to press this frame button, and we should see the laser trace out this little box on this piece of cardboard. Great, so I'm just looking to make sure that it's not going to go outside the cardboard. It looks pretty good. I'm going to move it just a hair in and a hair that way. Let's do another trace. Oh, that's too much. I don't want to waste too much of this piece of wood. One more time. Close enough. Next step is I have to drop that laser down so that it's actually a lot closer to the wood, because that's where the focus point is. Okay, let's drop that onto that piece of wood. It is a few millimeters off the wood, the thickness of this little scrap. And I think we're ready to do a test cut. I'm gonna open the door to vent this room a bit because it's gonna make a bunch of smoke. All right, let's see if this works. It's going to start by tracing all the numbers. Let's see if we can see any of the markings, or if that's too dim. Might need to rethink how this is set up on this table. Everything is shaking far too much. Okay, we're going to stop and try this again. Okay, I've dropped the laser to just off the print bed with that little spacer. Let's do one last frame, make sure it's still looking good, and see if we see any letters appearing. I can smell some burning wood. Looks like I might need to up the power a bit for these letters. Yeah, not seeing anything. We're going to cancel this and start again. Let's reduce the speed to 3000 and up the power to 70%. And go. Anything? Ah, there we go. I can see him now. Now I'm really smelling the burning wood. All right, now we do those serious cuts. Definitely don't want to look at that laser. slow moving, this is going to generate a lot of smoke, slow moving one in the corner at 10%, and we're going to let this run. It says it'll take 20 minutes to do this whole burn. So I will go ahead and just fast forward through this in the video. Ooh, that's a powerful laser. We do not need to go up to 100% on that. Frankly, I probably don't even need to test at 50 increments. Okay, I'm gonna stop this because based on this, it is way too powerful. Okay, so based on this, even at 30% at this slowest, it's punched directly through it. So I'm actually gonna go and drop these 50s, and we're gonna start at 200 and then go up to 1,000, and then we'll just have fewer of these. And that'll also make it this whole thing take less time. Because these are all punching straight through, and I really wanted to get a sense of more of this range to see how fast I can go and how little power I can use. So I'm gonna reconfigure this in Lightburn, and we'll try another test cut. Okay, so I've got a new test card here. This time we've got the speeds 100 through 1200. So a little bit faster and half the numbers, so it should go a lot faster overall. I decided to keep 100 here because I do want to see the gradient, and even though I know that 100 power at 100 speed is way too much, but we're gonna keep it like that for now. Can't wait to see how it does once we get up to here. So let's plug this in, turn this on, and get this one cutting now. I'm now realizing that, of course, I forgot to put a border around it, so it's just sitting there in the middle of this giant piece of plywood. I'm gonna see if I can just make a border around it and have it burn just that to cut this thing out of this piece of wood. So I'm just gonna draw a rectangle around this, about where I want it. Put it on layer, I know 100 at 80% cut through cleanly. So I'm gonna put it on layer 0, and we're gonna set it to 80%. And then I'm gonna just toggle the rest of these off. And with any luck, if I send this to the printer, to the cutter, it should just do that outline for me. So let's try that. Okay, close enough. Let's do it for reals. We're gonna move that dotted line to layer 26. All right, it's done. Let's shut this thing off and take a look at what we've got. There we go. All right, so looking at this, you can see most of these. Top row did a clean cut all the way through, and then we start getting to some that did not go all the way through. If you look at the back, clearly these did not go all the way through. So this gives us some working information. We know the fastest we can go on the lowest power and cut through reasonably is 200 at 70% power. This was all one pass. I could probably do 2 passes a little bit faster and get through, but if we just do 1 pass, we should stick to speed 200 at 70. It would be nice to know what we can, it looks like the fastest we can go and get good quality engraving is 1200. So I'm gonna adjust my test card to do these text labels at speed 1200 at about, I wanna say, let's say 50% power. And that should make these numbers show up better. And it would be nice to know if we can go any faster to get through the wood, but it looks like any faster we're gonna have to do another pass, which kind of negates the point because then we're just spending twice as long. So with this information, I should be able to plug in the numbers to do the actual cut of the panel itself. I'm going to do the cut throughs at speed 200, 80% power just to be safe, and any etching I'll do at speed 1200. So let me go set that up, and then we'll do the burn. So I'm actually not going to start it at the home position. I'm just going to push this into place about there. And we're going to use that frame feature again to see if that's going to have enough room. Oh, nope. Looks like I need almost that full piece. I think I need to rotate my piece of wood. Let's go like that. And start it right at the edge. Okay, let's see if this frame catches it all. Almost. So what we're gonna do is change my design to not do the box cutout like that. So I'm actually going to hide that frame layer and make a new layer for it that just does a cut on the top and on the bottom. And I'll overcut the wood. And that is going to go on a different layer. Use layer 3 for that. At 280. What's the height of this? 160 millimeters. So I do want to be that height. That one. Let's leave those off and see if the rest of it is going to fit. Maybe I can scoot these in a little bit. Okay, let's frame that out. There we go. So it jumps in, traces the panel. I want to scoot this a little bit more to the right. There we go. All right, I guess we're good. Let's turn that cut line back on for that. Let's do one more frame test with the cut line. These are gonna go all the way past the board. Yes, perfect. All right, here we go. Okay, now the serious cuts, going all the way through to carve out the slots for all the parts. This is making a lot of smoke. Like that. That was good. See all that smoke coming out from the underside? That is the reason you want this honeycomb. Otherwise, the smoke has nowhere to go. And here we go, final cuts to trim this into the final panel. And we're done. Let's get this thing off the table and into the studio, see what it looks like.
All right, overall, I think that went pretty well for the first try. I now have this panel cut out with all the little holes for all the different electronic components I'm going to put into it. A couple things I learned from doing this, a couple of mistakes, although I think this is still usable. Thankfully, this text looks fine, but I made a mistake because I didn't triple check my settings in Lightburn. The mistake I made in Lightburn was not triple checking the pass count. I actually had the layer for the text set to 2 passes. So it did everything twice. Went through the whole thing and then went back into the whole thing again, which just took a lot of extra time that I did not need to spend on that. The other thing I learned from this is that I had this text layer set to fill, which makes sense. I didn't want it to trace an outline of the letters. On my test card, I had done this using the outline, but on this one I did the fill, which meant that my numbers, of course, didn't match. And it turns out drawing a tiny line on the test card is actually quite a lot different than what it does when it does the filled text. The way that it does this is it goes kind of like back and forth, blinking the light on and off as it's getting over the letters. So between the power setting and speed not being exactly right and having 2 passes on this, this went almost all the way through. And thankfully it didn't punch all the way through, but it got dangerously close on that part. This is usable, so I'm not going to redo this board, at least not for the first trial of fitting all the parts, but next time I'm definitely going to do this differently. I think the key thing there would be to do a totally separate test card, filling these little squares in instead of doing them as outlines. That way I get a good test for how the fill pattern actually will affect, not just doing the outlines. I'll do that again before I do the next version of this panel. If I have to redo it for some other reason, I'll do a separate test card. The other part about that was that even at 1200, this took a long time. It took a long time to do the text burn. And I would really like it to go a lot faster. And given how far this made it through, although granted this is 2 passes, I'm pretty sure I could have gone a lot faster than 1200 and still had perfectly readable text. So I'm gonna keep that in mind again for the next burn. But overall, I'm pretty happy with the card. I am going to start doing the test fits of all the parts to make sure that they fit, and then do the rest of the project, which is going to be a lot of electronics wiring and then programming. But again, overall, I think that was pretty good for my first attempt at doing this. So the laser wasn't terribly difficult to figure out, just a couple of these little details to iron out for next time. So again, I want to say thanks to Atomstack for sending this laser over to review, and make sure you're subscribed to follow along with the rest of this project. We've got a lot more of this project to go, and I'll be sure to document it along the way. Then I'll get to actually being able to test these live streaming devices with this Chaos router, throttling the bandwidth, introducing packet loss, and all that stuff. So thank you so much for watching, and as always, I will see you in the next one.